Hello everyone. My name is Soumya Jagirdar and I'm going to present our work, Look, Read and Ask, Learning to Ask Questions by Reading Text and Images. This is a joint work with my advisors Shankar Ganki Shetty from Keli Technological University and Anand Mishra from IIT Jodhpur. Conversational AI is an exciting and emerging area. Technologies such as Google Assistant, Alexa, Siri are getting used in our day-to-day lives. Human-robot interaction and even robot-robot interaction are no more just science fiction movie things. Tasks that mimic human conversation are a huge set of responsibilities of a conversational AI. Therefore, building a conversational AI system that can make smooth and meaningful human-like conversation is the need of the hour. Our document image analysis community has also started showing interest in this problem of developing agents that can communicate with humans by introducing works that impact conversational AI and visual dialogue agents such as TextVQA, a text-based visual question answering system which introduces a new dataset that highlights the importance of text in the scenes to answer the visual questions. On the similar line, the ICDAR 2019 Robust Reading Challenge on Scene Text Visual Question Answering also introduces a new data set in which questions can only be answered by reading text in the images. Another work, that is Text Caps Challenge, in which dataset for image captioning with reading comprehension was introduced, where it proposes the idea of using textual cues to generate appropriate and more meaningful captions for images containing text. Other works such as OCR PQA, Knowledge Aware PQA are also a few works which have contributed in this interesting domain. Now let us look at an example of a possible conversation between human and robot in a text VQA kind of environment. The conversation could look something like, the man asks, "What is the name of the book?" The robot, after reading the content of reading the text present in the image, can answer Harry Potter and Deathly Hallows. After this, the conversation simply dies. Now, the challenge here is that can the robot also ask a follow-up question? It could be something like, do you want to know who wrote this book? The answer to this question is yes. As these works are performed in an environment of text-based visual question answering, this results in a limitation of one-way communication, which becomes a big hurdle in better visual dialogue systems. To solve these, we introduce a novel problem of generating questions using text and image, which attempts to solve these hurdles. That is, given an image and an OCR token with respect to that image, the task of the text VQG system is to generate an appropriate question for which the considered OCR token acts as an answer. Here are some possible set of applications for the proposed task, which include visual dialogue system, automatic text VQA dataset creation, a tool for visually impaired, and a question generation system in educational systems. To solve this task of text-based visual question generation, inspired from baselines in the work Generating Natural Questions About an Image, we provide three baseline approaches to solve this problem. The first one is Maximum Entropy Language Model. Here, a set of OCR tokens extracted from image along with a set of detected objects using FastRCNN are fed to a maximum entropy language model to generate an appropriate question. There are few limitations of this approach, which include no usage of multi-model fusion module to combine the visual and the textual features of the image. It also does not consider an answer to generate a question. The second baseline approach is sequence-to-sequence model. In this baseline, we first obtain a caption of image using a pre-trained CNN LSTM caption generator. Then, the generated caption is appended with the identified OCR tokens from an image, which is later passed to sequence-to-sequence model to generate an appropriate question for the given input. One of the limitations of this baseline is that it considers only the captions along with the OCR tokens to generate the questions. The third baseline approach is gated recurrent neural network. In this model, we first obtain the visual features using pre-trained image encoder. In this case, it is Inception V3, which yields a feature vector, which is then passed through a gated recurrent unit to generate an appropriate question. The limitation of this method is that it uses only the image features to generate questions. To tackle these limitations of baseline approaches and solve this new task of text-based visual question generation, we propose a new architecture called as OCR consistent look, read, and ask, OLRA, where the model is supposed to first look at the image, then read the content in the image, and later ask an appropriate question. I will be explaining the model in three components. The first one is look and read module. In this module, for an input image, we first extract the visual features using pre-trained CNN, that is ResNet50. The extracted image features are the first set of features called as phi-I. We use the OCR detection and extraction technique to obtain the OCR token from an image, which acts as a potential answer. We obtain the fast text features of the OCR token and pass it to the bidirectional LSTM to obtain the OCR token features phi-O. Based on various experiments, we found that the positions of the OCR token, which is acting as an answer, plays a vital role in visual question generation. Hence, we use the position features of the OCR token as phi-P. We concatenate the three feature vectors and pass it to a multimodal fusion module, which is a multi-layered perceptron. The output of the multimodal fusion module is a joint representation which serves as an input to the OCR consistency module and the question generation module. Now let us look at the OCR consistency module. After learning the joint representation of both image and OCR tokens, the model should be able to generate questions given specific token. To ensure this consistency, it is important that the joint representation learned after the fusion preserves the OCR representation phi-O. Towards this, we reconstruct the phi-O cap by passing the joint feature to a multi-layered perceptron to obtain the reconstructed answers, which basically preserves the token OCR token to generate an appropriate question. We minimize the L2 loss between the original answer and the reconstructed answer representation. Now let us look at the next module, that is ask module. In this module, the LSTM-based decoder generates relevant questions given an input image. We use LSTMs to generate the Q dash from the combined space from the multimodal fusion. The output of the multimodal fusion module, that is the joint representation vector, serves as the initial input to an LSTM. We produce the output of one word at a time of the question, one word at a time, using the LSTM. This happens until we encounter the end of sentence token, which basically does the task of question generation. The MLE loss between the generated and the true question guides the generator to generate better questions. The training of OLRA happens in multi-task learning paradigm for two tasks, that is OCR token reconstruction and the question generation. Coming to the results, we show our model's performance on two datasets, which are scene text visual question answering dataset, that is STVQA, and text visual question answering dataset, that is text VQA. As we can see from the table that our method outperforms the baseline approaches considered, those are MELM, sequence to sequence, GRNN, by a significant margin in all the performance metric considered on both these datasets. We provide two ablation studies. The first one is contribution of the individual components in text-based VQG system, and the second one is model's performance on N-word answers. Let us look at how different modules contribute to the generation of questions using textual content present in the image. Here, the first scores are where we do not consider the positions of the OCR tokens. The second one are the scores where we consider the positions of the OCR tokens. At last, we show the scores for the complete model with positions of the OCR token and the OCR consistency module. Now, let us look at how model performs with varying length of answers considered. The first row shows the scores for the model where the length of the answer is 1 word. The second case shows when the length of the answer considered is 2 words. And the third case shows where the length of the answer considered is equal to 3. Now let us look at some qualitative results. Here is an example of scene text VQ dataset where the following are the questions generated initially by the baseline approaches and the proposed approach and the expected question. As we can see, the proposed method generates questions similar to the ground truth questions present in the dataset. Now we will go through a few more examples and see how OLDRA generates questions similar to the expected questions. Here is an example of generated question compared with the expected question from STVQA dataset. Here is an example of generated question versus expected question from text VQA dataset. Here is another example where we compare the generated question with the expected question. After looking at all these scores and the ablation studies and these qualitative results, and looking at how the model performs even when the length of the answer considered is varying, one of the important conclusions which can be made is that we can automatically generate questions similar to the manually curated datasets. Here is an example of a fallback case from a method where the model misunderstands the content of the screen, content present in the screen as shown in the yellow box with the brand of the computer. So I would like to conclude by stating that we propose a novel task of text-based visual question generation, text VQG in short. We propose a model that asks meaningful questions about the text present in image, that is OLDRA. We believe that this captivating novel task encourages researchers to develop better text VQG systems, thereby promoting research efforts to the document image analysis community towards the conversational AI. And the code is made publicly available. Thank you, one and all.